Today we will look at 8.34 and 8.60 for the homework 15. So for the 8.34, we need to find the discharge ratio and the pressure differences expected for the prototype. So first we solve the discharge ratios. So we need to match the Reynolds number. So we know that the REM should be equal to REP. So we can get that the VM times the NAS LM over the new M should be equal to the VP times LP over the new P. And we can get that the VM over the VP should be equal to the LP over LM times the new M over the new P. Since we should the same fluid used, so this term should be equals to the 1. So we can get that the VM over VP should be equal to the LP over the LM. So we assume this is equation 1. And we know the ratio of corresponding area between the model and the prototype will be the square of the NANS ratio. So we can get that the AM over the AP should be equal to the LM square over the LP square. And we assume this is equation 2. And then multiply both sides of equation 1 and equation 2. We can get that the VM times AM over the VP times AP should be equal to the LP over LM times the LM square over the LP square. So we can get that the QM over QP should be equal to the LM over the LP. And since we know from the problem, the LM over LP should be equal to the 1 over 10, so we can get that the QM over QP should be equal to the 1 over 10. So this is the discharge ratio. And to solve the pressure difference, we need to match the pressure coefficient. So we know that CPM should be equal to the CPP. And we know the delta P M over rho M times VM square should be equal to the delta PP over the rho P times VP square. And we can get that the delta P should be equal to the delta PM times rho P over rho M times the VP square over the VM square. The same fluid used, so this term should be equal to the 1. So we can get that delta PP should be equal to the delta PM times the VP square over the VM square. And from the equation 1, we know that the VM over VP should be equal to the LP over the LM. So we can get that the delta PP should be equal to the delta PM times the LM over LP square. For a problem, we know the delta PM is 400 kilopascal, and the Lm over Lp is 1/10, so we can determine that delta P, the pressure difference for the prototype, should be equal to the 4 kilopascal. So we finished this problem. So for the 8.60, we need to find the proto discharge and the time for a particle to move in the prototype. So first, we need to match the first number. So we know that FRM should be equal to FRP. So we can get that Vm over the square root of the Gm times Lm should be equal to the Vp over the square root of the Gp times Lp. So we can get that the Vm over Vp should be equal to the square root of Lm over Lp. And we assume this is equation 1. And we also know the Am over Ap should be equal to the Lm square over the Lp square. And we assume this is equation 2. And multiply both sides of equation 1 by equation 2. We can get that the Qm over Qp should be equal to the Lm over Lp to a power of 5/2. So the Qp should be equal to the Qm times the Lp over Lm to a power of 5/2. And from the problem, we know the Qm is 0.1 cubic meters per second, and the Lp over Lm is 25. So we can get that the Qp should be equal to the 312.5 cubic meters per second. And then from the from equation 1, we also can get that the Lm over Tm divided by the Lp over Tp should be equal to the square root of Lm over Lp. And we can get that the Tp over the Tm should be equal to the square root of Lm over Lp times the Lp over Lm. So we can get that the Tp over Tm should be equal to the square root of Lp over Lm. And now the Tp should be equal to the Tm times the square root of Lp over Lm. And we know the Tm is 1 minute and Lp over Lm is 25. So we can get that Tp is 5 minutes. So we finished this problem.